battery for his backup battery for his...
Battery without battery.
Oh, I don't see without it.
Thank you. Ben, you were in my, was it PDP or
With all the
Science 10 or something?
Science and PDP, yeah.
Popcorn, I swear he had like a Hermione Granger bag and he would just reach in and it would be more popcorn. And more
Ben,
popcorn.
can we have some popcorn? That was biscuits?
Now it's biscuits.
Can I have some biscuits?
I like biscuits. Okay, so this is circular extensions HL part 3. If you go around a circle, you cover a distance of 2 pi r in a time period t. That's the period, it's just one revolution, right? Frequency is always the inverse of the period, right? If it takes you 2 seconds to go around, then you're gonna do a half a loop per second, yes? So this equals to 2 pi r f. If you're thinking angular acceleration, then whatever your radius is going to be the same number of radians. Does that make sense? Because remember, every radian of angle you cover, the distance on the outside is 1 radius. So if you're going to change this, so this is velocity, right? If you're going to change this into angular velocity, you do this divided by the radius. Because for your distance in meters, you would have, let's say, you would have the same number of radians, right? So you divide it by radians. And so this is just 2 pi. The other way to think of it is, if you go around a circle, you cover 2 pi radians of angle. So it's 2 pi per t, which is 2 pi f. Okay, so this is true. And this is also true. Your velocity, and this is why omega is this is why radians exist. Because your velocity is just your angular velocity times the radius. Right?
Nice.
And that has all kinds of applications when we do rotational motion, which we will not talk about now, but we'll talk about soon. Okay, you have these two things, and then I wanted to talk about just the link up of angular acceleration with these two things. So what's angular acceleration? It's a formula.
V squared.
V squared over r. So put this v in there, and we're gonna have, if we go like this, we're gonna have omega r squared over r, right? And of course we can, did I do that right? Yeah, that's right. And then if we put the omega in, we can say that's 2 pi f r squared r. Then multiple ways of doing this. You could get rid of the r first, but so this is going to be 4 pi squared f squared r. Right? Does that make sense? That is something that you need to keep in mind for when we do. I just want you to kind of see it. You might not remember the formula, but I just want you to remember how we got there. Like if you take omega and you take your velocity with omega, you can then throw that into centripetal acceleration and come out with a formula. So your centripetal acceleration is proportional to the square of your frequency and your radius. Okay, that's gonna come, it's nice with things like particles and light and things like that. We'll talk more about that later. I just want you to see it. Okay, I got some questions for you to do. Have I given you the Sokos book?
Yeah.
Okay. I shouldn't say that on video.
The physical copy of the circle.
Yes, right, that we bought and paid for. SoCo's page 266. I'm gonna lose my job. Again.
Yeah, again.
I just want you to do A, D, and E on number 12 and number 24. Oh, sorry. Thank you. So if you guys can do those, you should be good. And then we'll carry on from there.
Are you doing it now?
What time? How much time do we have left?
For like 2